Okay, I'm back, and now we want to do curved refraction. So just as a summary of what we've done, this one represents flat reflection. So a flat mirror, light coming in and then bouncing off of it. This one represents curved reflection, where light comes in, and then this one was an example of the convex mirror. And remember that there were two kinds. So you had the convex mirror and then also the concave mirror. And then we just got finished talking about refraction. And so this is refraction where you're going from one material into another material, but again, it's kind of flat like this. And then it's going to be refracted when it goes through it. So we could theoretically take this piece of material, whatever it is, and then physically bend it into a concave or convex type shape. But instead, we carve on it. And so when we carve on it, we're going to end up with two kinds of lenses. So we're going to have this one, and then we're going to have this one. So this one is going to be called a converging lens. And then this one over here is going to be called the diverging lens. And so this one is going to be similar to one of these two. And then this one is going to be similar to the other one. And so you're going to see which one is which here. So we're going to go to Phy Geometric Optics. Okay, and we've already done the mirror, so we're going to do the lens. Now, before you click on the lens, I want you to be, you have to be kind of fast when you do this. So you're going to click on the lens and then immediately click on none where it says rays. Okay, got that? None on the rays. So let me go ahead and click on it. None on the rays. And see, it got rid of those lines. Now your goal is you're going to redraw those lines and then use that to figure out where the image ought to be located at in a lens. So here is the lens. So this is the converging lens. And then here is our object. So the object is over here. And then this is going to be the image over here. Now your goal is to figure out where is that image going to be located at. Okay, now it says to take the pencil and move it over here. Okay, then you're going to make note of the image, and is the image right side up or upside down? And then also, is it large or is it small? Okay, then you're going to take the pencil and you're going to start moving it towards the focal point. So this is the focal point of the lens. And you notice there's two of them. So with the mirrors, there's only one. So this mirror has a focal point over here, and then this mirror has a focal point over here. But a symmetrical lens like this and this one has two focal points. And so you're going to take the pencil and you're going to move it closer and closer and closer, and you're going to be observing what's happening to the image over here. And now I won't do it for you, but something interesting is going to happen when you take the pencil and you move it into this region right here, when you get past the focal point. And then when you compare that to the mirrors up here, you will notice that the converging lens is similar to either this one or this one. And you need to figure out which one is which on that. So let's go back to the lab. Okay, and yellow dots are the focal points. This one was the converging lens. Click on none for the rays. Move the pencil to the far left. make note of what the image looks like, move the pencil towards the lens. How does the image change? Then you're going to do it for the diverging lens, so that you will go back to here and now click on this one, the hourglass one. So that changes it to a diverging lens. And you're going to repeat the experiment. So fill in all of this information here. Okay, then it says to change the lens back to the converging lens. So now we're down to here. We're going back to the converging lens, and I'm going to show you a way of geometrically figuring out where the image is going to be located. So this is going to be the geometric method of locating the image. So we're going to erase all of this. How's the weather where you're at? Okay, so we have our lens, and then the lens has a focal point on this side and then a focal point on this side. And then let me just use an arrow over here. So there's an arrow that's going to represent the object. So O for object, and then the goal is to geometrically figure out where is that image going to be located at. Okay, now we need to put numbers to this. So we need to click on the image of the horizontal ruler and move the pencil so that it's 200 centimeters from the lens. So a horizontal ruler, there. Okay, now we're going to move this thing so that this is going to be 200 centimeters from this. I believe that would be right about there. So you can do a better job than I can. And then we're going to move this back to here. Okay, so that the pencil is at the 0 mark, and then this is at the 200 centimeter. I hope I didn't say the word meter. So 200 centimeter. So this is going to be 2 meters away from it. Make a snip of this picture and paste it into Paint. So I won't do it for you, but you should know how to do it. So you're going to go, well, here's my snipping tool here, but I'm going to click on my snipping tool and then make a picture of this and then put it into Microsoft Paint, because what we're going to do is mark on the paint. So our first rule is going to be to make a horizontal line, a line that is parallel to this line here. So up here, where you're in Microsoft Paint, you're going to make a horizontal line, and then when it hits the center of the lens, bounce it through the focal point. So I'll let you do that with Microsoft Paint. So make a line that is horizontal, then when it touches the lens, then have it go through the focal point. Now the problem is we don't know how long that line should be. So we still don't know where the image is located at. We need 2 lines in order to be able to do that. So our second rule is going to be draw a line from here through the center of the lens. And this time, nothing happens. So it doesn't change direction. So we're going to make a straight line, and you see it doesn't bend at all. So this line, when it goes through the lens, does not bend. This one did, but this one doesn't. Now, can you figure out where the image is going to be? So do you see where these two lines came together? So now we're going to make a arrow, because remember, this is the tip of the arrow. And now this, that's my horizontal, that's my baseline there. Now there's a third one. Can you figure out what could you do with here, and then using this focal point, and then when it hits the lens, it ought to do something, and it ought to end up at exactly the same point over here. So I won't do that for you. Can you figure out what should you do with the third line that would end up over here? Okay, I'll let you think about that. Well, once you have done all of that, you can take a snip of Microsoft Paint and then put that in the lab for me so that I can see that you did the lab. And then what you're going to do is you're going to verify your answer by clicking here on Principle. So click on this one, Principle, and it will put up the 3 lines on this simulation, and you can see if you got it right or not. So I will let you do that. Now also, I need for you to take the ruler, and you're going to put the ruler over here, and I need for you to measure the distance from the lens to the image using the ruler, and that will be in centimeters. Okay, so this is all the stuff that you're going to be doing. And you're going to take that measured distance and you're going to put it down here. Now this one, distance from the focal point to the lens, so you can measure that with your ruler. Distance from the object to the lens, well, that's the 200. So we know what that one was. So that's 200 centimeters. Now you'll need to measure this one. So the distance from here to here, or the distance from here to here. Distance to the lens, distance from the lens to the image calculated. So I'll show you how to do that in just a moment. And then you also have distance from the lens to the image measured with your ruler. So you will put that number there. So the last thing that we need to do is to calculate where the image is going to be located at. And we'll do that in our next segment.